Hello, everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 4C. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development, ICT4SD 2026, in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today, that is 9th July 2026, in Goa, India, and the virtual event is being held through Zoom from 9th to 11th July 2026. I hope you'll enjoy the knowledgeable and interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be giving 10 minutes for the presentations and 2 minutes for question and answers. In 8 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me or to my co host in the chat box. Before we start the session, I would like to introduce you all to the session chair of this session, Dr. Varsha Zadhav. She is an assistant professor in the Department of Computer Engineering, Software Engineering at Vishwakarma Institute of Technology, Pune, with over 16 years of teaching experience. She's also a member of board of the studies for the department. Her areas of interest include machine learning, artificial intelligence, data science, data structures, design and analysis of algorithm. Ma'am, may I please ask you to share a few opening remarks?
Yes, thank you, Pranjal, for the pretty introduction today. And every time when I join this GR Foundation as a session chair in every conferences, I feel more and more happy. My happiness goes on increasing, and at the same time, the knowledge which I get from all the presented papers is beyond the limit. So it's really a very happy event for me to join as a session chair. And also, I would like to tell the authors that yes, all the conferences which are organized by GR Foundation, they are really very enthusiastic, they are really very fascinating and knowledge giving. So every time, at least one or two of my students, they have paper here. It is really very good when it is organized in Pune. I really do attend it in a physically. So it's really a very happiness thing that I'm again here with you all as a session chair, and I would like to thank the organizing committee for inviting me as a session chair. Thank you very much.
Thank you so much, ma'am. Now we'll be officially starting with the session. Now, I'd like to invite Meet Shah to present his paper on a hybrid deep learning framework for automated umpiring decisions in cricket. Mr.
Uh,
Meet Shah, you may
I
start presenting.
can't screen share my.
Just a minute. You can try now.
Yeah, thank you. This is my screen visible.
Yes, it's visible.
Yeah. Good morning, everyone. My name is Meet Shah, and the topic for my presentation is a hybrid deep learning framework for automated umpiring decision in cricket. So this is the agenda I'm gonna follow throughout the presentation. Introduction. Why cricket? Cricket is one of the sports that fascinates me a lot. And with respect to that, I have chosen this topic. So in cricket umpiring, it's majorly the main flaw is it's require high precision level. So like critical decision like LBW, run out, wide or no ball, it can be difficult to predict or decide with respect to the umpire. So the main challenges that human umpire faces are the reaction time, visual complexity, and the high match pressure. Existing systems still exist like Hawkeye and DRS, but it still requires some or other human intervention. Deep learning enables automated video-based event based on this event recognition. So basically, I have done literature review based on the different categories with respect to its key focus and the relevant papers. So which of the paper have used data set, like some of them has custom cricket data set, from some of them are from public and some are from various or multiple sources. With respect to that, methodologies and models that have been used, like some of them are CNN based, some of them are hybrid, some of them are deep learning, some of them are video based, or some of them are AI enhanced. Which performance metrics that have been used majorly are accuracy, precision, recall, and F1 score. Application challenges, so basically real-time umpire gesture, AI-based DRS and everything. Security and privacy concern majorly are that AI assistant decision verification for the fair play. Motivation, so majorly it reduces human error. It improves consistency, fairness, and reliability with respect to the decision. It moves from semi-automated to intelligent DSS. So basically, it utilizes CNN, REST, and LSTM for temporal modeling. So basically, it provides assistance to the umpire rather than replacing them. So the problem statement are, despite the advanced tool like DRS, systems are not fully automated. Some or what manual interpretation are still required. So the main problem is that I have been taken up is designing a hybrid deep learning framework for that automatically detects cricket umpiring events from the existing videos. It combines spatial and temporal learning and provides stable and consistent prediction. What are my objectives? So basically developing a deep learning based automated umpiring system and comparing the three deep learning techniques that have been used like CNN, ResNet and CNN plus LSTM. It is also performing video-based evaluation with respect to analyzing validation accuracy, confusion metrics, and annotated visual outputs. So dataset and pre-processing. So initially, I'm extracting the cricket match videos with respect to the data sources I'm getting on, extracting each frames at 5 seconds intervals, and with respect to that, I am dividing into the 9 event classes. So with respect to pre-processing, I am doing frame resizing, normalization, data augmentation, horizontal flipping, and random rotation. So this is the system architecture that I have followed. So basically, for initially, I'll input a video, start with the cricket video. After that, I'll extract frame with respect to 5 intervals. After that, I'll divide into a specific event category class. After that, we'll apply the techniques, the three main techniques that I've been using: CNN, ResNet, CNN plus LSTM. After that, I'll compare the technique with respect to the epochs and confusion metrics. And after that, the output video will be generated. So the key idea between the three different deep learning is like CNN provides spatial features, ResNet provides deep residual spatial learning, and CNN plus LSTM performs spatial temporal learning. These are the results and my observation. So basically, I have divided all the video with respect to the accuracy that I have got. So for one video, I have used three different epochs like 10, 20, and 30 to check whether it varies between the accuracy or not. So CNN has received the peak accuracy. ResNet is the stable across videos, and CNN plus LSTM provides better video output generation. So the main observation that I have been got that increasing epochs does not guarantee a better performance. With respect to the higher epochs, overfitting has been observed. So video-wise, evaluation is more realistic than dataset level accuracy. So I have also made a graph with respect to the techniques and divided them based on the three different epochs of accuracy that I have been received. So for example, for video one, the three different epochs is 10, 20, and 30 with respect to each and every video. So right now I have been taken only 10 videos. So with respect to that, I have divided into three techniques to three epochs. Same for the CNN and same for the CNN plus LSTM. So these are my results that I have been generated. So here you can see it's detecting and it's not playing. Here you can see it's predicting six. Here it's predicting no ball. Here it's predicting six. Here it's predicting wicket. Here it's predicting run out, legal delivery, and four. Here wicket and six. So I have inputted outputs of all the 10 videos that I have been tested till now. So this is the confusion matrix of the highest accuracy which I got. So it shows strong diagonal dominance. There might be still minor confusion between boundaries and wickets, but it still indicates strong discriminative capability, and similar events may cause errors. To conclude, like no single model of outperforms in all scenarios. As I said, CNN has the best accuracy, ResNet is stable, and CNN plus LSTM provides better video output generation. So system contribution. So basically, I've done video-wise evaluation, confusion matrix analysis, annullated video generation, and hybrid framework comparison. So to finally conclude, proposed system enhances fairness, consistency, and reliability. So for future plan, I have been thinking of including more and more videos to provide a stable accuracy. So these are the references that I have been used throughout my research. Thank you.
Yes, Meet, very interesting work. And my question is like, why did you choose algorithms and not some different?
I did research about it, like with respect, I've also done literature review of SVM and other machine learning techniques, but they don't provide enough output, and they have been using only one category, like only detecting boundary or a wicket. But I have
So
been,
have you mentioned it in the research paper that
yeah,
you
yeah,
have studied? Yeah.
I have
Yeah.
mentioned it.
Okay. And that your future work is like you're going to increase the videos.
Yeah, yeah, like
Yeah.
I'm
So the
gonna,
data set size will be increased.
yeah, for right now
So
also it varies
yeah.
from like some of 2 minutes,
Yes,
some of
yes.
for 15
My
minutes.
question is, when the data size increases, many of the machine learning algorithms, AI algorithms, or Gen AI algorithms, they work more or less efficiently and accurately, or they may give some less output also. So
Yeah,
depending on the data size also, you might have to change the algorithms there.
yeah. But I'm
Yes.
also
So
thinking with respect to that, a different system right now I was doing with respect to my laptop.
yes, one more system. There is a concept called as third empire.
Yeah.
So, what is the difference between your model, which you have developed, and the third existing empire?
So still third umpire also takes a few time. Mine will be the accurate. Right now it will be based on the video, but for the future respect, it can be with respect to the AI
See
integration.
what today I have read in some article is like in Bengal or some state of India that when NCRT was being designed is using the AI tools for writing the books. So for fifth
Yeah.
standard, there was almost 200 to 300 mistakes being done, and for some 8th to ninth class, some more number of mistakes was being done. So it requires some interference or some human being for analyzing that thing. So
Yes.
the third empire is actually watching the video and analyzing what was, whether it is run out or no ball or whatever the event or incident is.
Yes.
So any moment that if AI tool is creating some mistakes there, at the end it requires some human intervention for doing it. So
Yes.
would you like to comment on it?
Yeah, like it will not fully replace the third umpire, but it will help third umpire to finalize the decision at as early as possible.
Okay, okay, yes. Fine. Thank you.
Okay, thank you.
Thank you, Meet, for such an insightful and creative presentation. Now we'd like to move forward with the next presentator. I would like to invite Dharmendra Chauhan to present his paper on a hybrid intelligent MATLAB based GUI framework for early detection and localization of lung tumors using advanced medical image processing. You may start sharing your screen.
Yes. Good morning, all of you. I hope I am audible.
Sir, you are audible, but your
Yes.
voice is echoing.
Okay. Uh, Wait.
Sir, you may start with your presentation.
Yes. Hello. Now I am audible.
Yes, sir.
Okay. Thank you. So now I am going to share my screen. So I think my screen is visible. Hello.
Yes.
Yes, sir, your screen is visible.
Okay. Thank you. So my name is Dr. Dharmendra Chauhan. Uh, Today I would like to give the presentation on my conference article, a hybrid intelligent MATLAB-based GUI framework for early detection and localization of lung tumors using advanced medical image processing. These are the outlines of the article: uh, abstract introduction, problem statement, flow chart, result and discussion, conclusion, and future scopes. So basically, uh, actually, it is the lung tumor detection is a critical for effective treatment and patient survivals. So lung cancer is one of the leading cause of cancer-related death worldwide. So early and accurate detection can improve the patient survivals. Over here, we have proposed a system which is an automated tumor detection system using MATLAB GUI. So medical lung images are used as the input for the tumor detections, and the system performs the image processing, enhancement, segmentation, and future extractions. And these images are processing step by step, help identify the suspicious tumor rigorous region accurately, and the automated approach reduces the need for manual image inspections, and it minimizes the diagnostic errors and reduce the processing time. And our proposed system act as a decision support tool for the healthcare professionals. Introduction: lung cancer is the term for the cancer that originate in the lungs, and the lung cancer start in the lungs and can go other and spread it to the other organs, including the brain and lymph nodes. Now, to identify if the lung cancer is present or not, there are four phases actually. We obtain the CT scan picture data in the first image. In the second stage, we apply the picture enhancement to raise the image's quality. Images segmentation, which is a crucial stage in the diagnosis of cancer and is a third phase, right? Now, the process of future extractions, which determines whether or not lung cancer exists, is the fourth step. Problem statement: the manual lung tumor detection is the time consuming and may lead to diagnostic error due to the human subjectivity. And the existing diagnostic method require a faster, more accurate and automated approach for early lung cancer detections. There is a need for user-friendly computer-aided system that can accurately identify and localize lung tumors for from medical images. The objective of this research is to develop an automated lung tumor detection system using MATLAB. Now, to accurately detect and localize the lung tumor regions using image processing techniques, and to reduce the diagnosis time and to improve the accuracy and consistency for lung cancer detections. These are the steps for the detection of the lung tumors using an MRI scan as a source. to achieve the maximum intensity, convert it into the grayscale images. Now to avoid the to avoid obtaining extra data, adjust the MRI images by using maximum intensity level. Identify the head cross-section boundary through the translations of an MRI scan into binary images. Identify the head cross-section border and converting the altered image to a binary images. Identify the region impacted by the tumor and eliminating its border, presenting the performance parameter for both tumor affected image and normal images, and determine the tumor areas. These are the resultant discussions. The first of all, the CT scan images of lung affected. So this images is converted into the grayscale image to improve the visualization and highlight different intensity level. So this converted image is shown into figure 4. The figure 4 is the 3 cross 3 median filter. We are applying the median filter over a converted image. 3 cross 3 median filter was applied to remove the noise while preserving the tumor boundaries, and the 3 cross 3 filter provided the better result than the large window sizes. So this, after applying the medial filter, the we will find out the edge detections that's shown in figure 5. Actually, the edge detection was performed to identify the tumor boundaries. Now, two thresholds values were used to detect both strong and weak edges accordingly. Figure number 6. After the edge detection, the image segmentation was carried out using the k-means clustering algorithm to separate the tumor region from surrounding lung issues. Figure number 7 is the extracted tumor. The future extraction was performed by selecting the region of interest, that is ROI, and displaying only the detected tumor shape and locations. Now, the complete image processing pipeline successfully detected and localized the lung tumor with improved accuracy. The proposed MATLAB-based system provides a fast, reliable, and user-friendly solution for the early lung tumor detections. Lung tumor detection using 2D image processing. Over here, we have given the steps. First of all, the input images, then we are applying the median filter over the input images, then finally the edge detection, then segmentation, and then the detection of the tumor. So this is the actually the simulations of lung tumor images in a MATLAB. And these are the steps. We have provided the steps how to implement the GUI for the lung tumor detections. So same, the input images, median filter, edge detection, segmentation, and tumor detections. So over here, this is the design GUI of the uh, project, right? So over here, the final image is without tumor, and these steps already we have discussed. The MATLAB GUI provides a simple and user-friendly interfaces. The GUI includes 5 display panels, 5 buttons, and one lit title box. The figure 9 shows the developed MATLAB GUI. So these are the actually the advantages or what actually the MATLAB GUI provides, right? So median filter removes the noise, edge detection, detect the tumor boundaries, segmentation, separate the tumor regions, tumor detection, display the final detected tumors, and the figure 10 shows the GUI in run mode before processing, and the GUI performs the step-by-step lung tumor detection quickly and efficiently. So this is the figure number 11, and this is the figure number 10, right? So figure number 11 is the simulation of GUI with tumor detection. So over here, this is the simulations with tumor detection. So in finally, the tumors are detected. So figure 11 shows the MATLAB GUI in run mode before any processing is performed, and the input image button loads the lung CT scan image, followed by medial filtering to remove noise and enhance the image. Edge detection identifies the tumor boundaries, while segmentation separates the tumor region from the lung image. And finally, the tumor detection stage display the detected tumor, demonstrating the complete step-by-step workflow of the proposed system. These are the advantages of detecting the tumor using this proposed system, and some disadvantages: the accurate detection and localization of lung tumor. The performance depends on the quality of the input images. Reduce the diagnosis time and manual efforts. This required a proper parameter selection for optimum result. User-friendly interface, easy to use for non-expert. This may not detect very small tumor in some cases. Improve early detection and support better treatment. Expert validation
I'm
is
so
still
sorry
necessary.
to interrupt, Dharmendra, but
Yes,
now I'd ask you to conclude your presentation.
sure. Thank you. This proposed MATLAB-based GUI successfully automate the lungs tumor detection process while image pre-processing, median filtering, age detection, segmentation, and future extraction techniques. The system accurately identifies and localizes the suspicious tumor regions while reducing manual efforts, diagnostic time, and human errors. The experimental results demonstrate that the proposed approach is an effective and reliable decision support tool for the early diagnosis of lung cancers. The proposed system can be further improved by incorporating the advanced image processing, machine learning, and deep learning technique to enhance the detection accuracy and robustness. Future work may also include testing the system on larger clinical dataset, supporting real-time analysis of CT and MRI images, and developing a web-based or mobile applications to improve accessibility and clinical usability. So this is the conclusions of this research work, and some future work also we have presented over here. So we can use the machine learning and deep.
Yes, Dr. Dharmendra.
Yes,
Yes.
ma'am.
So, have you done validation with any cancer specialist oncologist?
Now not, ma'am. Just we have simulate in our laboratories. Few images we have taken,
Okay.
and it is
And
simulate in our lab.
were the images collected a realistic image, or from where you have collected the image data set?
Actually, we have collected the image dataset from the internet sources. This is not actually real images of the lungs tumor
Okay,
or
so
any CT scan images.
okay, fine. Thank you.
Thank you, ma'am. Thank you.
Thank you so much, Dharmendra, for that knowledgeable presentation. Next, we'll move on. Now, I'd like to call upon the next presentator, Vivek Dinesh Sharma, to present his paper on ESP32 based food spoilage monitoring and prediction using MQTT enabled IoT sensors. You may start sharing your screen. Mr. Vivek?
Am I audible?
Yes.
Yes, you're audible.
Yeah, just a second. Yeah, so is my screen is visible to everyone?
Yes, Vivek, your screen is visible.
Yeah. So good morning, everyone. My name is Vivek Dinesh Sharma, and today I'm presenting. Uh, my project title is ESP32 based food spoilage monitoring and prediction using MQTT enabled IoT sensors. Uh, This research is also being presented in the ICT4SD conference. So over the next few minutes, I will walk you through the outline and the core problem of my project and the topic which I have decided to cover. Globally, like we see a massive amount of food is wasted before it ever like reaches to those in need. So my goal is to secure a supply chain like by combining continuous IoT sensors tracking temperature, humidity, gas and moisture. So we are using four sensors for detecting and predicting the spoilage of the food before it getting spoiled within AI predictive layer. Uh, so by using it, we can detect spoilage before it becomes visible, and we can proactively alert our nearby NGOs also for the redistribution of those food. This is the problem statement which we identified. So currently one third of global food is wasted. Why? Because the industry relies on subjective visual checks, a fixed expiration date, or every food has a fixed what you can say a shelf life. So based on that, storage units are isolated and there is a massive logistics gap. So by the time someone notices the food is going bad or going to spoil, it's already like too late to donate it or to use those food. So that's why we identified this problem. And the motivation behind is this technically we are bringing high edge AI technology and a low cost hardware also, which will target the sustainable development goals for specifically for distributing the spoilage food, and for you can also turn it into a smart redistribution unit. So these were the two main impact factors based on which we identified our motivation behind this project. So our main aim is uh, to build an intelligent, cost-effective prediction and redistribution system. Uh, the objectives were to first build an ESP32 based hardware prototype. Second is to establish a lightweight MQTT communication protocol pipeline. And third is to we have trained a random forest machine learning classifier model. And finally, we have built a real-time dashboard and alert system for alerting the nearby NGOs and food distribution areas. So these were the objectives as I already mentioned. Yes, yeah. We have done the literature review, we have highlighted the trends and gaps of the current which the current existing systems doesn't have. So we reviewed the recent papers 2024 and 2025 papers, while a few authors like Sonwani this literature review, so they have great accuracy in their system using like CNN or ensemble regression techniques, but their systems were either computational heavy, or they lacked edge deployment, or they were only focusing on monitoring those food items. They were not actually predicting. So we have identified the drawbacks and limitations in the existing literature system. Uh, so the like yeah, these are the literature review for those research papers we have done. Uh, so for the proposed solution, so for the hardware we have upgraded like from a basic node MCU to the like ESP32 dev kit version 1 for its like dual core pre-processing power. Now also we have integrated a DS18B20 which is a temperature sensor, uh, DHT11 for the humidity of the food, and a MQ4 gas sensor, which will like whenever the food is into a very spoiled atmosphere, like for example in summers, like the tendency of food is to get spoiled earlier in terms of like other environment. So there we have used like MQ4 gas sensor and a capacitive moisture sensor for predicting the input for the food. So we have sample data we also have a sample data like every 500 milliseconds, which we have applied to the threshold logic, and it will like directly provide us the bandwidth for the prediction. So yeah, uh, so moving on to the methodology part, like let's start with the hardware flow. So we specifically chose to upgrade, like as I've mentioned, from a Node MCU because it gives us a dual core processor. Also, it has higher accuracy in predicting the necessary output we required for this prediction. Our sensor array like includes temperature sensor, humidity, and MQ4, which is for gas. This sample data will provide us the necessary threshold logic. Like we have set here, like for temperature it is less than 25 degrees Celsius, for humidity less than 50 degrees Celsius, and for moisture also we have set the specific threshold. Second is the software workflow. So here is the workflow, like including different layers such as edge processing layer, communication layer. Third is cloud and AI layer. So first we have received our data through cloud. Second is we have stored our data. Third, we have using random forest for and we have taken the database across 50 food types for this prediction. If these are redistribution logic, like how we are going to redistribute the food. Also, one thing to highlight, like if the spoilage risk hits like a critical warning state, so our automated like logic triggers will like alert the system to use that food quickly before the
I'm
food is
sorry to
getting.
interrupt, Vivek, but now I'd request you to conclude your presentation.
Yeah, sure. So this is the block diagram which I have explained. Uh, Flowchart, everything which I've explained through the, yeah. So these are the results. I'll show you actually. Yeah. Yeah. So these are the results. Like this is the actual hardware on which we have like tested based on three different food types. First is like fresh apple. So we evaluated like our random forest classifier like over 1500 curated samples across 50 food categories. So we achieved on fresh apple we achieved like a test accuracy of 99.4% like by optimizing the decision splits using we have used the Guinea impurity metric. Second is the cooked sabji. So here the output was a little discrepancy in the output. So it has like shown in the results. third is we have tested on the ripped banana. So it also like the temperature and humidity was a bit different as compared to apple, but it was also in the fresh state. So these are our actual results based on the samples. And based on our research, we have done the comparative analysis between our existing system and what we are proposing. So here I have highlighted. And to conclude, I'll like the system successfully bridges the gap between like passive monitoring, which the current systems are doing, like uh, and what our system is doing, like actively like impacting the main driven system which we have implemented. And we plan to implement further we can like implement it to redistribute in a better way so that it can reaches a maximum area. So these are the references I've used. Yeah, I'm done. Thank you.
Yes, Vivek. Yes, you have identified that apple, ripened banana, and cooked sabzi. So, what was the logic used to identify the food, whether it is cooked, uncooked, and what is the possibility that only good food goes to the NGO, not the spoiled food?
Good food. Yeah, ma'am. Like we have identified, like we have tested, based on we have created a customized data set, and we have tested across 50 food types. So based on that, we have created uh, whether the food is cooked or raw, like based on different food types.
Hmm.
Yeah. So
Okay.
basically, every food type, like in raw state. So apple is in raw state. So for that, we have different readings for humidity.
Okay.
For
Have you done any validation?
Yes, ma'am. I have done validation. I have also compared it with the SCADA dataset, and I have verified it, and then only I have like implemented the
Okay.
results.
Okay. Thank you.
Yes, ma'am. Thank you so much.
Thank you, Vivek, for such an engaging presentation. We'd like to call the next presentator, Tashvi. I would invite you to present your paper on expression-based movie recommendation system using ResNet 50 for enhanced emotion detection. You may start sharing your screen.
Okay, thank you. Pranjal, can you confirm if my screen is visible?
Yeah, your screen is visible.
Good morning, everyone. I am Tashvi, and today I will be presenting a project titled Expression-Based Movie Recommendation System using ResNet 50 Enhanced Emotion Detection. In this project, we combined facial emotion recognition with user preferences to recommend movies that matches both the user's current mood and long-term interest. Let me walk you through the presentation. So the first slide includes the content of the presentation. So let's begin with the abstract. The objective of our project is to make movie recommendations more personalized by considering the user's current emotional state. Traditional recommendation systems only depend on watch history and the ratings. As you can see in Netflix, we have a specific panel there to select what type of movie we want to watch, like if it's horror or funny or anything. So our system first detects facial expression and using ResNet 50 deep learning model through a webcam, and then it combines the this emotion with the user's previous viewing behavior using hybrid recommendation approach. Movie information is fetched using the MDB API, and finally the system recommends movie that best matches both the user's mood and interest. Overall, this model achieves high emotion detection accuracy while generating recommendations quickly in real time. So what we know is today's OTT platform like Netflix, Amazon Prime, and Disney Plus offers thousands of movie and TV shows. Although this provides user with many choices, it also creates a new problem known as content overload. Users often spend several minutes searching for something to watch instead of actually watching a movie. Existing recommendation systems mainly depends on the historical information, such as watch history, ratings, and previously liked movies. However, these systems cannot understand how the user feels at the current moment. Human emotions play a significant role in entertainment choices. For example, if someone is feeling happy, they may prefer comedy or adventure movie. If they are feeling sad, they will prefer something to boost their mood off or something in a very motivational side. Recent advances in artificial intelligence and computer vision allows us to detect facial expression accurately. Therefore, by combining real-time emotions detection with user behavior, we can generate recommendations that are much more personalized and relevant. The main objective of our project are first to develop a real-time emotion-aware movie recommendation system. Second, to use the Resnick 50 deep learning model for accurate facial emotion detection. Third, to combine emotional information and behavioral data like watch history and ratings. We also aim to reduce irrelevant recommendation and improve user satisfaction. So the final approach will be the system is designed to be scalable, efficient, and suitable for real-time deployment. Let me walk you through the analysis of problem. Existing recommendation system have several limitations. The first issue is that they ignore the user's current emotion state. Another common issue is the cold start problem, where new user receive poor recommendation because there is a little historical data available. Traditional system also tend to recommend similar content repeatedly, reducing users' engagement. Therefore, a hybrid approach combining emotion and behavior provides a better solution. Our project requires both hardware and software components. We use a webcam to capture the user's facial image. Deep learning model detects the user's emotion from the captured image. The detected emotion is mapped to suitable movie genre. We also collect user interaction such as rating and watch history. Finally, the TMDB API is used to retrieve the movie information and generate the recommendation in real time. So for the project, we have done some literature survey. Before developing our system, we studied previous research, and Yehuda Koren introduced matrix factorization technique that improved collaborative filtering. Pezzini and Bilisis worked on the content-based filtering, which recommends items based on similar features. Robin proposed a hybrid recommendation system that combines multiple recommendation techniques. Uh, we also studied lightweight models such as MobileNet V2, which reduce computational cost and support a real-time application. Researchers also use API like TMDB for dynamic movie information. However, many existing systems still struggle to combine emotion detection and user behavior efficiently. So our project addresses this gap by creating a hybrid recommendation system that is accurate, scalable, and suitable for real-time use. The working process of our system consists of several stages. First, the webcam captures the user facial expression. The image is pre-processed by resizing and normalization before being sent to ResNet 50 model. The model predicts the user's emotions such as happy, sad, angry, surprised, or neutral. Next, the behavioral data is uh, collected, and the emotion score, behavioral score, and the movie popularity score are combined using hybrid scoring mechanism. Finally, the system recommends the most suitable movie and continuously updates recommendation as the user behavior changes. So this is the flow chart. That is exactly what I just explained to you guys in the previous slide. The workflow is the user's live facial expression is captured, the image is resized to 224 by 224 pixels and normalized before entering the deep learning model. The model predicts the user emotion. and the recommendation engine combines this result with the user's previous preferences. So finally, we get the recommendation of movie that are displayed on the screen. So this slide shows the Android interface of our application. The user can view recommended movie directly on the mobile devices. The interface is simple, responsive, and designed for real-time interaction. The recommendations are automatically changed whenever the detected emotion changes. The slideshow desktop version of the application, it provides the same recommendation functionality with the larger and more detailed interface. Users can browse, recommend, and explore movie details and receive updates, uh, suggestion, and all. This is the result and discussion slide. Our system achieved promising results. The overall model accuracy is approximately 96%, with precision and recall and F1 score high as well. Emotion detection alone achieved approximately 89.4% accuracy, and the detection process takes only 20 to 30 milliseconds, while movie recommendation are generated in approximately 300 milliseconds. We also observed improved recommendation quality with higher precision, better ranking using NDCG and more personalized suggestion compared to traditional recommendation system. And we also noticed that as per the passing epochs, the accuracy increases. To conclude, our hybrid recommendation system successfully combines spatial emotion detection with behavioral data. ResNet 50 provides high accuracy emotion recognition, while the hybrid recommendation approach generates a more relevant movie suggestion. Compared to the traditional systems, our solution adapts both the user's current mood and the long-term preferences, resulting in better personalization and user engagement. In future, we plan to include voice emotion recognition, multilingual support, and reinforcement learning for continuous improvement and deployment on cloud platform to support larger number of users. So these are the references that we concluded, and that's all from my side. Thank you so much.
Yes, Tasvi, good presentation. And
Thank you.
you said you have done some emotion predictions.
Yes, ma'am.
So what are the different categories of emotions you have predicted?
Ma'am, we have predicted angry, emotional, happy, surprised. These are
Okay.
the basic human emotions that we could.
And what was the logic being used to identify or predict that emotion? Suppose say it's happy emotion and
Yes,
sad
ma'am.
emotion. So how did it differentiate it?
Ma'am, sorry if you can explain or elaborate a bit.
Okay, thank you.
Thank you so much, Tashvi, for such an engaging presentation. Next, I would like to invite, just a minute. Yes. Next, I'd like to invite Mansi Chandwad to present her paper on Givista, a multi-category donation platform with rule-based recommendation and location-aware matching. You may start sharing your screen, Mansi.
Yes, ma'am. Uh, so, Good morning, everyone. I am Mansi Chanwar, and today I will be presenting a research work titled Givistha, a multi-donation platform with rule-based recommendation and location-aware matching. Uh, our problem statement. Before developing Uvista, we studied the limitations of existing donation platforms. We found four major problems in the existing donation platforms. First was the most platforms do not support monetary donations and ignore physical goods and blood donations. Second, there was no single platform that integrates all donation categories into one. Third was the donors cannot easily track how their donations are utilized, which do not ensure trust. Finally, urgent requests, especially the blood requirements, are often not prioritized efficiently. These limitations motivated us to develop Givesta. uh, the proposed solution that we gave was to overcome these challenges. We developed a unified donation platform. Our platform combines monetary donations, physical items like books, clothes, etc., and blood donation prioritization in one ecosystem. It verifies NGOs before allowing participations as well. It also automatically recommends the most suitable requests using AI rule based prioritization and location aware matching. With location aware matching, what I mean is I will be able to donate within my range of location, which will improve transparency, efficiency, and accessibility for both donors and the recipients. uh, this is our system architecture. This slide illustrates our three-tier architecture. On the left is the donor tier. It consists of the web application used and made with Flutter. In the center is the Givista platform core, which contains the rule-based recommendation system, Google Maps API for location awareness, and the transaction gateway and donation tracking. Finally, verified NGOs, hospitals, and beneficiaries from the recipient tier. This modular architecture makes the platform scalable and easy to maintain. uh, these slides implements the core features we have implemented into our Givista. Our platform consists of six major features. First, it supports multiple donation categories, not only financial donations. Second is blood donation requests, which are prioritized according to urgency. Third is NGOs can create and manage verified donation requests. They can create a open chat where people will be able to donate um, various categories like clothes, book in bulk, and both of the recipient and admin will be verified. Then is the donation tracking. Donors can track the complete donation process, from received to dispatch to everything, improving transparency. The fifth one will be recommendation system. This will be an AI recommendation engine, which will suggest the most suitable donation opportunities. And finally, the Google Map, which will help match nearby donors and NGOs, reducing travel time. Uh, the formula we have used for rule-based prioritizing and proximity of optimization is priority score, as shown in this slide. Mm. This is the main contribution of our work, the rule-based recommendation engine. Instead of using complex machine learning models, we use a transparent scoring mechanism, the formula that is shown on this slide. The priority score depends on three parameters: urgency, proximity, and reliability. And the urgency ensures critical requests receive attention first. Then proximity reduces the delivery time using Google Maps, and the reliability considers verification of the NGO performances. This approach is very simple, explainable, and computatively efficient, and that is why we have used this. This is the system differences in the existing donation category platforms and the platform we have built, Givesta. As you can see, there is only financial tracking which is given in other existing donation platforms, but we have all the multi-category accessibility on our platform. Uh, Also, there is no location matching in other donation platforms, no prioritizing, ranking, and no blood donation management, but we have added all of it into it. Broadening access and cultivating social trust. Now, what is the social impact of our Givista project? Our project benefits multiple stakeholders. Donors receive personalized recommendation and complete transparencies. NGOs reduce manual effort in managing donations. It will be helpful for the NGOs to receive the donations as well, and it is effective in all the processes. Hospitals and community organizations receive faster responses for urgent blood requirements. And overall, Givista helps build trust and encourages greater public participation in charitable activities. We have also included gamification into our Givista, which will give batches to the most, like for the most efficient donor as well, and the donor with highest donation rates, etc. The system outcomes and future framework. Our evaluation shows improved efficiency in donor recipient matching and reduced travel distance through location awareness recommendations. In future work, we plan to integrate machine learning for demand prediction and blockchain technology to further enhance transparency and security. Thank you.
Ma'am, do
Yes,
you have any questions for her?
yes, Mansi, good work. Yes. What was the motivation for your project?
Um Motivation. So, first of all, we wanted to build a project for our college, but then we got to know a professor of ours had an NGO. They were organizing, but then we thought, why not build a system where donors and recipients match each other without finding, like for example, I am organizing an NGO myself, but I am in need of clothes right now, but I
Okay,
can't.
fine, Mansi. Have you done validation?
Yes, ma'am.
How?
Validation is through, so what the validation we have done is basically authentication, like the NGOs, donors and recipients will be verified with the OTPs, email OTPs, and KYC verification.
Okay, thank you.
Okay.
Thank you so much, Mansi, for contributing to this session. Next, I'd like to call upon our next presentator, which would be Vasundhara Bindal. I'd like to invite you to present your paper on green communication systems and consumer behavior, ICT-based sustainable marketing approach. You may start sharing your screen.
Can you hear me?
Yes, Vasundhara, you're audible.
Okay, ma'am. Okay. Good morning, ma'am. My name is Vasundhara Bindal. I'm from Graphic Era, deemed to be University, Dehradun. And today, it's my pleasure to
Sorry
present
to
our
interrupt,
research paper.
Vasundhara, but your
Yes, ma'am.
presentation is not visible.
Okay, ma'am. Okay, wait just a minute.
Yeah.
Ma'am, can you hear me?
Yes, Vasundhara, you're audible.
Ma'am, my screen is visible or not? I have shared my screen.
Yes, your screen is visible. You may start with your presentation.
Okay, ma'am. Good morning, ma'am. My name is Vasundhara Bindal from Graphic Era, deemed to be University, Dehradun. Today, it is my pleasure to present our research paper titled Green Communication System and Consumer Behavior, an ICT-based sustainable marketing approach. In this study, we explain how ICT such as social media, website, digital platforms helps companies communicate their environmental activities. We also explain how it communicate increase consumer value, influence consumer behavior, and improve organization performance. Now, let me briefly introduce this study. Today, sustainability is becoming very important because uh, because the world is facing problems like climate changes, pollution, and environmental damages. Because of these problems, people are becoming more aware of the environment. The most preferred product that are eco-friendly and made by companies that care about the environment. To meet these expectations, many companies are using green marketing. Green marketing means promoting products
Vasundhara, are you there?
Hello.
Yes, ma'am.
Yes, is the presentation going on?
No, ma'am. I think she has some technical glitches. She's not audible, nor is her screen
Okay.
visible.
Okay. We'll further proceed for other presentation till she
Yes, ma'am.
gets connected.
So we'd like to proceed for the next presentation. I'd like to call upon Naval Lavande to present his paper on mapping the intellectual landscape of workspace incivility, trends and future agendas. You may start sharing your screen.
Uh, Good morning, everyone. Am I audible?
Yes, sir, you're audible.
Is my screen visible?
Yes, sir, your screen is visible.
Okay, I'm just putting it in presentation mode. Yeah, is it now showing the presentation?
Yes, sir.
Okay, thank you. Good morning to the chair and the organizers. My name is Dr. Naval. I'm from Symbiosis Institute of Management Studies, Pune. Um, I'm presenting on mapping the intellectual landscape of workplace incivility, the trends and future agendas. This is a bibliometric study that I have done on workplace incivility. So just to give you a context, first, of course, the concept of workplace spirituality from an Indian context revolves around primarily high power distance, basically indicating how does the power emulate in the organization. And of course, the collectivist orientations which shape what workplace incivility is perceived, enacted, and tolerated. Now, the existing research has primarily focused on internal organizational outcomes, okay, like stress or disengagement. But very few attention is given on its implications, right, which might be internal as well as external. So there's no scientific mapping or an attempt to map that literature of this domain that has been done in the past. So, to address these gaps, this study tries to pursue three objectives. The first one, of course, is to synthesize the global trends and the clusters in the workplace. The second is to kind of identify a pathway to linking incivility and customer relationships, especially in the banking sector. And finally, of course, to attempt to propose an approach which positions digitalization as the moderator for this study. So, just to touch upon a little bit of literature, how an incivility actually came into existence. It's basically a rude or discourteous behavior, which is ambiguous. The intent is no harm. But in the banking environment, such behavior, commonly appears as a very curt communication, an email neglect, delayed responses. We're all familiar with that, and exclusion of colleagues and sometimes customers in the communication. Now, the challenge also that organizations and even literature says is that banks today are employing kind of four generations, right? From the baby boomers to the Gen X to the millennials to the Gen Z. So each one has a distinct communication expectation and sensitivity threshold, of course, right? So this is leading to that misinterpretation and rudeness that is perceived. So digital incivility also has become something that has been there around for almost 2 decades now. So since the evolution of the computer and internet, so the digital incivility again erodes a lot of trust and deteriorates the collaboration, brings in stress, burnout, work quality gets affected. We see turnover, absenteeism, and stuff, right? Recently, for example, we're talking about things like quiet quitting, right? That is happening because digital incivility also is playing a crucial role. Now, these are the dynamics that actually complicate the human resource management. And so this is the study where we are trying to find out what does literature say, and can literature actually give us some idea of what we can do in the future. So this is just in terms of the methodology and the design, right? So the primary data that was there was from two databases that I scraped. One was from Scopus and the other being Web of Science. These are the best databases that we could pick up. The time span that I have taken is from right from 1999 to 2025, and the table on the left shows us, the various aspects in terms of how many documents, sources that were touched upon. Now, the other thing that I kind of filtered out is, of course, I limited the study to only English language. And of course, in terms of articles, I took all kinds of articles. It could be journals, conference papers, book chapters, and so on and so forth, right? So this filtration led to the study having about 994 documents, which was then using R programming and the package of BiblioShiny in the R Studio that was used to do the analysis. Now, the analysis was primarily showing three or four aspects, which is descriptive, data visualization, and stuff. So let's come to some of the key analysis that I have touched upon in the paper. So first up, of course, you'll notice, I know it might not be very legible, but I'll read out to you. On the extreme left, where I'm having most relevant journals being showcased. Okay, this is what I'm talking about. So for example, the top three journals that kind of showcase include, Journal of Occupational Health and Psychology, which is the leading source, which is having a good 3 digit in terms of the publications. Then we have the Frontiers of Psychology and Journal of Nursing Management, Current Psychology, which are substantial contributors. So we'll notice that they are the three journals. So in terms of publications, clearly workplace incivility seems to be a keyword that is driven in terms of publications. Looking at the scientific production and growth, now right from 1999, we see that it's steadily moving and fluctuating sometimes. But once we reach somewhere around 2014, right, there is a spike that happens, right, and that's when we notice that there is a huge increase in terms of the growth, number of publications that's happening. Now, this is indicative of managerial interest, and this is where I mentioned about human resource management playing a key role, right? Then, of course, you see a little maturation that happens after 2022. The reason primarily for that could be that, the domain is saturating, and then the field is getting matured enough, right? Because there are other terminologies and keywords, like I mentioned, quiet quitting coming in and stuff. Now, moving to the growth path, right, and how the publication shows in, if you try to put it into the concept of a S curve. Now, the S curve clearly suggests that there is a transition, right, in terms of the emerging maturity of workplace incivility as a concept, right? So you can see that going up, and somewhere around maybe 2030-ish, we notice that the term kind of is plateauing, right? And hence the growth on that terminology, maybe from 2025 also or 2030, we'll notice that it will die out. So this was the first set of analysis that we could identify. The second is the word cloud. Now, the word cloud gives us a good indication of which are the keywords that are getting linked to workplace incivility, right? So it's very obvious that incivility, for example, does become critical. But what are the other terminologies that are coming in? We look at stress, for example, that is there, but it's also impacting the performance of employees. So again, is workplace incivility something that needs to be dwelled upon on its implications, right? And its digital incivility also coming into play. So we'll notice that other stakeholders, like for example, the customer is getting impacted because of that. There is incivility at the workplace. You'll notice that another stakeholder like the customer being effective. Similarly, in terms of the keywords, you'll notice that terminologies like behavior are coming in, right? Impact on organizations is coming in. It is clearly indicating there is a moderating role that is being played, right? It is impacting performance. So this is another set. The final set of analysis is pretty critical in terms of how workplace incivility is important. Now look at the thematic map, right? Now the thematic map shows us obviously that on two aspects. Centrality means the criticality of the concept or the keyword, and density means the weightage in terms of measurement. Now you look at workplace incivility being decently high in terms of the density and decently very, very high in terms of the centrality. So it clearly is a motor theme. Now, motor theme identifies it as a driver, right? Which means workplace incivility is definitely one of the themes that is driving as far as other aspects of business are concerned. Now, again, if you notice that job satisfaction and burnout performance seems to be having a decent centrality, but even in terms of density, it is on the lower side. Now, this also is kind of trying to tell us that look, there is an indication of interconnectivity between each of these concepts, right? And hence that takes us to the co-occurrence network. Now, you look at the co-occurrence network, obviously, workplace incivility will be targeting incivility, but there is other aspects, right? For example, it's linking to especially a particular gender. So I know this is not very visible, but I'll just read out it's female which is written, right? So which means again workplace incivility is having a skewness towards a particular gender, so that's a pretty interesting thing. Other is in fact in terms of bullying, right? So huge bullying is getting related to that too. Of course, when we look at the two clusters, it is clearly saying that workplace incivility is not only restricted to the workplace, but even general incivility kind of is getting intertwined.
I'm so sorry to interrupt,
Yes.
Naval, but
Yeah.
I'd like you to conclude.
Yeah, this is my conclusion slide. So if we have to conclude, then I would say that workplace incivility, of course, is a circumstance that has huge consequences. So including stress, it acts as an antecedent for lots of uncivil interactions that can happen. Now, why is this coming in? This clearly there is a generational diversity that is creating this complexity. Of course, what do we need to do in terms of the future? One is, of course, the cultural sensitivity that needs to be brought in. Technological information is very critical, right? Use of technology, right? System level approaches to ensure that civility is taken care of. And finally, organizations kind of have ignored this aspect, so they can create more positive and thriving work environments that address workplace incivility. So these were the references, and I can take a few questions now.
Yes, Dr. Naval. Yes, good work. And
Yes, ma'am.
what is the difference between bullying and incivility?
Incivility, ma'am, will also is the parent to bullying. So bullying is the observational action that you will be able to see, right? But workplace incivility need not necessarily be in terms of behavioral patterns that you might notice. So it is very difficult, right? You might not send a mail directly to somebody which is offensive, but you might, for example, not mark a CC to a customer or a particular employee which is critical to that project. That includes incivility. In case of bullying, there is an attempt to, in terms of a behavioral pattern, to downgrade someone.
So, have you studied any realistic part of incivility in any of the workplace?
No, ma'am. So this is currently the precursor study. So right
Okay,
now, I
okay.
first wanted to
And
test and check.
what challenges did you face while studying?
No, so since this is primarily in terms of a good literature survey to help us identify where are the gaps. Like for example, digital incivility is very predominant when it comes down to the Gen Z, but might not be very critical in terms of or significant in terms of
But
baby boomers.
there may be challenges present also. So you need to do
Yes,
it. If you're
yes,
going to enhance your research work, you
correct.
should identify the challenges and
Yes,
accordingly you should proceed for it.
yes. Ma'am, so that's why the presentation in the conference, and hopefully now with these inputs from your side,
Yes,
plan to now
yes.
take this study even further by actually capturing, authentic data using tools.
Yes. Okay. Thank you, Dr. Naval.
Thank you, ma'am.
Thank you so much for such a wonderful presentation. Now, I'd like to still confirm if Vasundhara is here.
Yes, ma'am.
Vasundhara, can you present now?
Yes, ma'am. Yes, ma'am.
Okay, please go ahead with your presentation.
Ma'am, my screen is visible now?
Yes, your screen is visible.
Okay, ma'am. So, good morning, ma'am. My name is Vasundhara Bindal from Graphic Era, deemed to be University Dehradun. Today, my paper title is Green Communication System and Consumer Behavior and ICT based Sustainability Market Approach. In this study, we explain how ICT such as social media, website, digital platforms helps companies communication their environmental activities. We also explain how these communication increase consumer value, influence consumer behaviors, and improve organization performance. Now, let me briefly introduce this study. Today, sustainability is becoming very important because the world is facing problems like climate change, pollution, and environmental damages. Because of these problems, people are becoming more aware. To meet these expectations, many companies using green marketing. Green marketing means promoting products and businesses practices that are good for environmental. Another factor is ICT. ICT today's company use social media, websites, mobile apps, and digital platforms to share information about their green products and environmental activities. This helps consumer understand the product better and build trust. However, we still need to understand how ICT based green communication influence consumer behavior. So, in this study, we propose a framework that explain how green communication system influence consumer perceived value, which affects consumer behavior and finally improves organization performance. Moving towards the literature review. Previous research shows that green communication enhance companies to promote eco-friendly products and adopt sustainability business practices. This is also motivates consumer to make environmental responsibility purchase decisions. Another important factor is that ICT enables green communication. Researchers have found that companies using social medias, websites, AIs, and other digital platforms to communicate their green investigates the improvement, transparency, increase consumer awareness, and build trust. The literature review also highlights the importance of CPV, that is consumer perceived value. In this, CPV means the consumer see the value of a green product. It has three parts: emotional, environmental, and social value. Next, in this, we see the organization perceived value. In this, they build a better brand image, increase consumer loyalty, and achieve sustainability business growth. This called the organization perceived value. So, the literature shows that the green marketing practices, ICT and CPV, consumer perceived value, and OPV, organization perceived value, is all important. However, these concepts have mostly been studied separately, which lead to the research gap in our study. Now, after viewing the previous study, we identify an important research gap. Many researchers have studied green marketing and ICTs, but most of these studies have been looked at them separately. Few studies explain how ICT green communication creates the value of consumer and how it is finally to fulfill these gaps. Our study proposes an integrated conceptual framework. The first objective is, is to study how ICT enables green communication, influence sustainability consumer behavior. The second objective, the second objective is to examine how green communication improves consumer perceived value, including environmental, emotional, and social values. The third objective is to understand how higher consumer perceived value helps improving organization performance values such as better brand reputation, consumer loyalty, and sustainability business growth. These objective provides the fundamental form of proposed conceptual framework. Moving towards the conceptual framework of this study, the framework is main concept our study, our research. It is explains how ICT enables green communication, creates value for consumers and organizations. The main framework have four main parts that are: first is green communication system. This is the starting part of our framework. It includes online green advertising and ICT based sustainability. Companies using digital platforms like social media, websites, and online campaigns to communicate their environmental. The goal is to make consumer more aware of green products. The second part is consumer perceived value. This means how consumers see the value of green product. Three main parts, three main values: environmental value, emotional value, and social value. The third part is consumer behavior. When the consumer more value in product, they are more likely to be buy the product, trust the brand, and stay loyal to the brand. The final part is organization perceived value. When the consumer buy and support green product, organization also benefits. They build a stronger brand image, customer loyalty, and achieve sustainable business growth. So the framework shows that effective green communication creates value for consumers, which lead to positive consumer behavior and find improves consumer performance. Based on the framework, we have four hypotheses. First hypothesis is consumer perceived value have positive effects on consumer perceived value. Better green communication creates high value for consumers. Next, second is consumer perceived value has a positive effect on consumer behavior. It Ma'am, I am audible.
Yes, you're audible.
Okay, ma'am. Okay. Now, H2, that is consumer perceived value, has a positive effect on consumer behavior. H3 is consumer behavior has a positive effect on organization perceived organization value. H4 is green communication system have a indirect effect on organization performance. This happens through consumer perceived value and consumer behavior.
I'm so sorry to interrupt, but I'd request you to conclude your session now.
Okay, ma'am. To conclude, this study shows that ICT is an important part of green communication. When companies use digital platforms to share their green activities,
Yes,
consumer understand.
yes, Ishan.
Yes, ma'am.
Okay, okay. If you could please wait for 10 to 15 minutes, I'll be right back.
Okay, ma'am.
Sorry, yes, uh, Vasundhara, are you there?
Yes, ma'am. Yes, ma'am. Yes,
Yes,
ma'am.
yes, yes. So, have you gone through any practical work?
Practical work like,
Have
ma'am.
you have you done any practical work for this paper?
Ma'am, this study is based in secondary data.
Okay.
Yes, ma'am.
So, what was the motivation behind writing this paper or doing the things or doing the research?
Ma'am, motivation what?
Why did you thought that you should come out with this topic? Are you there, Vasundhara?
Ma'am, the main motivation behind this study is that environmental sustainability and digital technology are becoming very important today. Many companies are using ICT to promote their green products, but previous studies have mostly examined green marketing and ICT separately.
Okay, thank you.
Okay, thank you, ma'am. Thank you so much.
Thank you so much, Vasundhara, for your presentation.
Thank you, ma'am.
I'd like to call upon our next presentator, Amruta Mhatre, to present her paper on plant disease classification with early stopping and using deep learning.
Am I audible, ma'am?
Yes, you're audible. You may start presenting your screen.
Uh, is my screen visible?
Yes.
Okay. Good morning, everyone. Myself, Amruta Matre. Along with Dr. Pranali Chaudhary, I am presenting this paper titled Plant Disease Classification with Early Stopping Using Deep Learning Models. Outline of the presentation is motivation, need of disease detection in tomato plants, literature survey, comparison of models, methodology and hyperparameters use, analysis with imbalanced and balanced data set, early stopping, then results and conclusion and references. Motivation for selecting this topic is basically world needs to produce more food due to population growth, and crop diseases have become more concern as it affects the plant growth and reduce the yield production. Manual inspection is slow, subjective, and dependent on expert knowledge. Deep learning offers an automated path for faster and more scalable disease diagnosis. Now, it is a need of disease detection in tomato plants. As we all know, tomatoes are everyday crop that promotes agricultural diversity. It powers the food processing sector and essential for feeding world's expanding population. Tomatoes are one of the most widely grown and consumed vegetables, both in fresh and processed food markets. Diseases and pests that appear in fields can easily infect tomatoes. Hence, early detection of disease is necessary in order to improve the crop production. Various climatic conditions and other factors affect the growth of tomato plants. Rather than such climatic conditions and natural disasters, plant diseases are the primary reason for production crashes, resulting in less tomato field and financial disaster. We have done some literature survey where we have seen in 2025 the worldwide production of tomato plants by China was 64.8 million metric tons, whereas in India it was 20.6 million metric tons. In 2024, tomatoes produced by India were 21.32 million metric tons, whereas in 23 it 48% of the tomatoes were produced by China and 14% of the tomatoes were produced by India. This was the statistics from year 2016 to 2022, where we can see China is in the range of 58 to 68 million metric tons of tomatoes they are able to produce by China, whereas India continuously we are in the same range where we are producing 18 million metric tons or approximately 22 million metric tons of tomatoes. And this was possible due to huge well-developed industries which are available in China. That is why, in spite of having the similar kind of land or even the less land than India, they are able to produce more tomatoes. This was a literature survey of already existing work which is done in the field of plant disease classification. We have observed that ResNet 50 is giving the, compared to other existing deep learning models, ResNet 50 is giving the good accuracy that is in the range above 95%. We have done the comparison of four different models here. VGG16, ResNet 18, ResNet 15, ResNet 101. VGG16, it is a classic deep CNN which tagged by 3x3 convolution. It is strong baseline but higher parameter count and slower computation. Whereas ResNet 18, it has shallower residual network with the lower compute cost. ResNet 50, it allows deeper learning with manageable complexity and best results. ResNet 101 has 101 layers. It is very deep residual network with stronger feature capacity but higher training cost than ResNet 50. These are the comparison of all the four models in terms of floating point operations and parameters. This is the methodology which we have implemented by performing this analysis. We have collected tomato leaf plant images of 10 classes, including healthy leaves and 9 diseases from publicly available dataset, that is plant village dataset. Then we have pre-processed using resizing to 224 by 224 and ImageNet normalization. Then split the data into training and testing sets with 80:20 ratio. Then we have applied a transfer learning with 4 CNN backbones and then compared performance with imbalance and balanced data sets. These are the parameters, hyperparameters, which we have used for our analysis. For analyzing this data set with imbalanced data set, I'm saying imbalanced because we have considered 10 different classes and each different class has a different number of samples. So total 14,529 images were available with the 10 different classes where we yellow leaf curve, bacterial spot, and late blight. Those are the diseases which contribute the maximum samples. That is 52% of the data were for these three classes, and remaining 7 classes were contributing 48%. So what we have observed is that imbalance harms generalization and class level consistency. Accuracy is highest for well represented classes like bacterial spot and yellow leaf curve. Performance drops as soon as the sample size is less. Comparing all the 4 models, what we have observed that ResNet 50 has the most consistent model across all the classes, and VGG16 generally underparts on difficult categories. This was the comparative analysis of our data set and the accuracy which we have got after the analyzing all the 4 models with the 10 different classes. So we can observe here that early blight, where the samples are only 55% of the entire sample size, it has a lower accuracy. With balanced data set, what we have done is we have considered all the 10 classes. Each class has a similar data size of 1,000 images. So what we have observed that, and this data size where we were having very less samples, we have used the data augmentation by flipping, rotating, changing the brightness and contrast. We have tried to manage generate those 1,000 samples. So goal was to improve class fairness, strengthen robustness, and reduce the distortions caused by imbalance. Then we have implemented early stopping for this balanced data set. The purpose of implementing early stopping was training will stop when validation loss no longer meaningfully improves using patience equal to 5 and delta equal to 0.01. This helps limit overfitting and cuts wasted computation, which matters for edge device deployment in smartphone. Early stopping is basically a regularization technique used in iterative machine learning algorithm to prevent overstopping by terminating training before convergence on the training data. Early stopping is validation-based stopping criteria that halts training when the model's generalization performance shows saturation. It monitors the performance on held out validation sets and stops training when validation stops. Loss stops improving for a certain number of epochs called patience parameter. So in this case, we have considered the patience parameter as 5 where that means if validation loss does not improve significantly for 5 consecutive epochs, the training will stop.
I'm so sorry to interrupt, but now I'd request you to conclude your presentation.
Yes, concluding. These are the results where we are getting ResNet 50, accuracy of 25.25% with ResNet 50. This is the curve that we are getting where we can see ResNet 50 has got good accuracy and the less training time compared to all other 4 models. Concluding my presentation, residual networks outperform the VGG baseline for tomato disease classification in the study. Data set balance matters. Shift from imbalance to balanced data improves reliability across classes. Early stopping is an effective as a practical regulation method that improves generalization and avoid unnecessary epochs. ResNet 50 gives the best accuracy to efficiency balance and making it a recommended architecture among those tested. These are the references. Thank you.
So it was a good research work. And what data set you have used?
Ma'am, we have used a publicly available data set from Kaggle plant village data set of 10 different classes of tomato
So
diseases.
have you focused on any region?
For real time data sets, we are trying to focus on that different regions in Maharashtra. Like I have collected some real time samples, but in this analysis, first of all, I'm using publicly available data set to analyze the performance of that model. Then I'm going to implement those models with my real time data sets. This I'm focusing with the different environments and different regions. I'm going to
any particular region, name of any place that you're focusing on?
Solapur, ma'am.
Solapur, okay.
Yes.
So the yield of tomato is more in Solapur?
Yes, ma'am. There are more farms that side.
I think throughout Maharashtra, the yield of tomatoes is good. And if the tomato is having some disease, so which part of that plant you are considering to identify the disease?
Leaves, ma'am.
Leaves, okay.
Yes.
And what will be the methodology being used there?
Ma'am,
These are all existing algorithms, na, which is giving
Yes.
accuracy. And if it is your research work, I think you should come out at least with some hybrid method or some algorithm which should show some good accuracy as compared to that of
ma'am.
the existing methods.
Yes.
Yeah.
This was actually for my understanding how these models are working, so that I have used the existing data set and existing models. Now my
Yes,
next
and
task is to implement
at the
that.
same time, if you are using some Kaggle data set and the realistic data set, there will be some challenges which you will be facing
Yes, ma'am.
while the data set is being changed.
Yes.
Yes, so
I'm
you
actually
have
working
to
with that.
look for it. Yeah.
Yes, ma'am. Sure.
Yes, thank you.
Thank you so much, ma'am. Thank you.
Thank you so much for your presentation. Next, I'd like to call upon Chitrashri Kotkoti to present her paper on optimized deep learning for robust Android malware detection, zero-day resilience, explainability, and edge deployment readiness. You may start sharing your screen.
Hello, am I audible?
Yes, you're audible. Your voice is low.
Hello, ma'am.
Yes, please continue.
Good morning, Chair and Organizing Committee. My name is Chitrashri Kurtkoti. Today I'll be presenting my paper on optimized deep learning for robust Android malware detection, concentrating on zero-day resilience, explainability, and edge deployment readiness. So this is my research study, which proposes a lightweight and adversarial robust deep learning approach for the detection of malware on Android devices. So this approach is actually aims to address the emerging threat of malware attacks, especially those based on zero-day and evasion attacks. So this will be overview of my presentation. So first I'll be talking about motivation and research gaps I have identified. So then I'll be proceeding to the proposed framework. So then we'll be discussing on results and future study. So why I'm concentrating on malware on Android? So because the Android has witnessed a significant increase in the market share. So currently it is exceeding almost 70%. So then consequently, the Android platform has attracted increased considerably attention from the cyber attacks. So this, given this widespread use in the critical activities, so as we use in banking, healthcare and communication, the exploitation has increased by the cyber attackers. So hence, so there is a urgent need to develop effective mechanism for detecting various types of malware attacks. So previously, we are also having traditional malware detection mechanisms, which are mainly based on the signature-based techniques. However, these approaches have proven to be less effective in identifying a broad range of malwares, evolving malwares. So hence, we are concentrating on the model, so which can also detect the zero-day malware attacks. So, so as we have identified main four research gaps, these are the argumentative attacks continue to pose serious threat.
Yes, your slides are not moving.
Now?
Slides are not moving. It is on the first slide.
Just ma'am, now?
Yes.
Is it visible?
It's visible. Continue.
Oh. So the critical issue here is the lack of interpretability. So many models are lagging in the interpretability. These models often produce predictions without providing a clear explanation. So which is undesirable to security sensitive applications. So then we have one more research gap, that is existing models require substantial memory and computational resources. So making them unsuitable for deployment on mobile and edge devices and in IoT devices. So additionally, there are limited research has been conducted on the systematic evaluation to impact the optimizers on learning rates. So in order to consider these research gaps, we have developed a model based on the DNN. So here are the objectives of our study. The first one is the DNN-based malware detection. So here we are using DNN deep learning, deep neural network. So various recent papers have employed the use of DL techniques for detecting Android malwares. So we such as Chronoid, and also based on the other DNN models. So these techniques achieve strong performance. However, certain limitations are there, which are very susceptible to attacks, and usually understanding the reasoning behind them becomes quite difficult. So they lag in explainability. So second, we are concentrating is on optimization. So we have used 3 different optimizers for optimizing learning rates. So third one is we are concentrating on adversarial vulnerability and robust training. So our model will be our model will be deployed for adversarial attacks. So then we are using quantization using the TensorFlow. So we have also added explainability to our model. So that is using Lime and Sharp. So these are the objectives. So this here is our proposed system. So this proposed system consists of several main steps. These steps are getting the data ready, making DNN model using the proposed system, the training and applying a method called as quantization. So here this system shows feature extraction, model training, and adversarial training, also using the quantization and explainability. So here we are using Trebin dataset, which is consisting of total 15,000 samples. Within that, 5,000 will be malware samples and 9,000 will be benign samples. So we are mainly taking 200 most relevant features, and we are training our model. So then we also said that we are using the adversarial robustness. So here it is evaluated using the fast gradient sign method, that is FCSM. So where bounded perturbations are applied to input features to simulate evasion attacks, such as permission manipulation and feature obfuscation techniques. So here these multiple perturbations levels are tested. The model is trained using combination of clean and adversarial samples. So, and both the model is tested before adversarial and after adversarial testing. So here we have the success rate is before it is 17% and after adversarial it is 3.5%. So we have, as I told, we are using quantization. So we are applying quantization so that the model can be deployed on low resource devices. So for this, we are using TensorFlow Lite. So the dynamic range quantization is applied using TensorFlow Lite to compress the model and reduce the inference latency. So, and it also maintains the accuracy, improving deployment efficiency on resource constrained devices. So here, the original model accuracy is 93.52, and after quantization, it is 93.16. So there is a negligible accuracy drop, that is 0.36.
I'm so sorry to interrupt, but I'd request you to conclude your presentation.
Yes. So these are a few of the results which we have achieved 99%. So, as I told you, our model is tested before adversarial attack and after adversarial attack, and also few of the samples are made like 0 day, which are not trained before, and we have also recorded that result, and we have also added explainability by using Lime and Sharp, so which gives both local and global feature importance and explainability. So, and this is the comparative study, how the previous studies are, what is the accuracy of previous study using Trebin and different data sets, and how our study is having accuracy. So finally, conclusion and future work: a lightweight, adversarial, robust, and explainable DNN for Android malware detection is used. Also, it uses the TF light quantization trims, which is useful for IoT devices and Android, where the resource is constrained. And it also uses Lime and Sharp together to expose the reasoning behind the detection. And future work will be, so actually this work is for static samples, and which will be extended for further for dynamic analysis. and it will be validated on a larger and more diverse malware data sets.
Yes, Chitrashri. Yes. So, what is the why the optimized deep learning is considered more effective than the traditional antivirus software?
Sorry, ma'am, I did get.
Why your research work is considered more good than the
Okay.
traditional antivirus software?
Antivirus softwares, so most of the antivirus softwares are not zero-day resilience, ma'am. They are not zero-day resilient because so they will be trained based on the known patterns. So most of them use the signature-based techniques. So like they are trained on the known patterns by the attackers. So in our model, we are using that zero-day resilience.
Okay, thank you.
Okay.
Thank you so much. Now we'd like to move on to our next presentation. I'd like to invite Kadambari Raghuram to present his paper on security, privacy, and machine learning in the Internet of Things, challenges, architectures, and applications in intelligent agriculture. You may please share your screen.
Okay, ma'am. Am I audible, ma'am?
Yes, you're audible.
Okay. Is my screen visible? Is my screen visible, ma'am?
It's not.
Is it visible now, ma'am?
Yes, sir, it's visible. You may start your presentation.
Okay. Good morning. Good morning, respected session chair and the coordinators and fellow participants. Myself, Kadam Ragram, from the research scholar from the Department of Computer Science Engineering, National Institute of Technology, Silchar. Today, I am going to present my research work titled Security, Privacy, and Machine Learning in the Internet of Things: Challenges, Architectures, and Applications in Intelligent Agriculture. So before I discuss the technical details, let me alone. Okay. So before I discuss the technical details, briefly explain about the flow of my presentation. I will begin with the research problem, inspired the work, introduction, security, and the results and the future work. So what motivated me to do this particular work? Now you know that the Internet of Things has become one of the fastest growing technology in the recent years. In agriculture, particularly, IoT sensors helps the farmers to monitor the soil moisture, temperature, humidity, rainfall, and other environment conditions. So, however, as the number of connected devices increases day by day, the attack surface also grows significantly. So, most IoT devices have limited memory, processing capability, and battery power, making it difficult to implement the traditional security mechanism. Therefore, ensuring the security without compromising the system performance has become a major research challenge. So, although IoT provides the enormous benefits for intelligent agriculture, several challenges are still remaining. So, agriculture IoT devices are usually deployed in remote and unattended environments. So, that make them vulnerable to physical attacks, network attacks, and application level threats. At the same time, these devices have limited computational resources, which restrict the implementation of conventional security techniques. In addition to security, agricultural monitoring will also require highly accurate machine learning models for real-time prediction and decision making. So the problem addressed in this work is how to design a secure IoT architecture that provides a strong security while simultaneously supporting the efficient and accurate machine learning for intelligent agriculture. Now I'd like to summarize the major contributions of my research. Firstly, we performed a comprehensive study of IoT security threats across the different architectural layers. Secondly, we summarized the existing mitigation techniques and mapped them to their corresponding security layers. Thirdly, we proposed a security IoT architecture specifically designed for precision agriculture. And fourthly, we did validated the proposed architecture using controlled threat team attack simulations to evaluate its security performance. Finally, we compared 5 different machine learning regression algorithms and identified the most suitable model for soil moisture protection. Let us go to in detail about the 4-layer IoT architecture. This is the standard architecture. The first layer is the perception layer. It consists of sensors, RFID devices, and actuators. They interact directly with the physical environment and collect the data. The second layer is the network layer, which is responsible for securing and transmitting the collected data using communication technologies, LoRaWAN, Wi-Fi, and cellular networks. Third layer is the middleware layer. This layer will perform the data aggregation, storage, processing, and management before forwarding the information to the cloud services. Finally, we have an application layer. It provides the intelligent services such as precision agricultural, healthcare monitoring, in industrial automation, and smart city application. Every layer introduces different security vulnerabilities. A comprehensive security mechanism is required throughout the entire architecture. So now you see the here the majority security threats present in IoT system. At the physical layer, devices are vulnerable to RFID cloning, firmware extraction, and side channel attacks. Then coming to the network layer, attacks may perform the eavesdropping, man-in-the-middle attack, denial of service attacks, and botnet-based attacks. The application layer is also vulnerable to insecure the APIs, weak authentication and mechanisms, and malicious input injection attacks. So as we can observe from this following figure, threats exist across every architectural layer. So we are implementing security only at one layer is insufficient. A layered security strategy is essential for protecting the modern IoT systems. So the IoT security mitigation by architecture layer. After understanding the threats, now we are examining the corresponding mitigation strategies. At the physical layer, secure boot mechanisms, hardware security modules, and physically unclonable functions helps to protect IoT devices against the cloning and firmware attacks. At the network layer, we are having a protocol such as TLS and DTLS and LoRaWAN encryption provide secure communication
Are you there?
Yes, there is a disturbance.
I think, ma'am.
Okay, okay. So I think he lost his connection. No problem. Should we stop?
Yes, then
Yes.
we'll be going ahead. Now, I'd sincerely like to thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough on behalf of the whole team. Thank you for your support during this 11th version and all the 10 previous versions of the conference. We'll be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I also thank our session chair, Dr. Varsha Zadhav, for chairing the session. As a token of appreciation, I'd like to display this
Hello,
certificate.
ma'am. Hello,
Yes,
ma'am.
sir.
Due to internet connection, there is a power off, ma'am. I request the session chair to accept my consideration. There was a power failure. I switched it to my mobile net. So please consider let me allow to complete the presentation. I
Sir, you can
request the
show your
session chair and the
results.
organization.
You can show your results and conclude.
Yes, sir. There's a time crunch, so please
Okay, ma'am.
just show your results and conclude.
Sure, ma'am. So this was the empirical study we did. You can see the security validation results over there. So after developing the proposed architecture, we performed the empirical study validation through controlled red team attack simulation. 5 different attack scenarios were considered. Is my screen is visible? I think
Yes,
my
yes,
screen is
please
visible now, ma'am.
proceed. Yeah.
Are you able to see my results? Yes, yes. Thank you, ma'am.
Yes.
So as shown in the table, reply attacks achieved a detection rate of 98.6%, while denial of service.
Okay, Pranjal, let's conclude.
I think he just joined, ma'am.
Okay.
So are you there? So you're not audible. So you're not audible? I think
Yes.
there's been a technical glitch.
Yes.
Then I'd like to move on. I appreciate our session chair for guiding this session, and as a token of appreciation to the chair on behalf of Team ICT4SD 2026 and Global Knowledge Research Foundations and partners, I would now like to invite you, ma'am, to kindly deliver the closing remarks.
Yes, thank you, Pranjal. Thank you for the great opportunity. And thank you for the organizers, Amit Joshi sir, and everyone, Nilanjan Dey sir, for giving the opportunity for such a good and knowledgeable session. And I could have knowledge from all the authors who have presented the papers, including the cricket match, then the medical imaging, image processing for identifying the tumors in lungs, and the IoT sensors for identifying the spoilage of the food and providing it to the NGOs in a good format, the movie recommendation systems, and also the multi-category donation platform for recommending the local aware machines, then the incivility which was being presented in a very good sense, then Android malware detections, and the plant disease classification, especially for the tomato plant, and also the challenges in of internet and its architecture in agriculture, in security and privacy. Yes, it was a little bit technical glitch there, but everything that which has taken place today was greatly knowledgeable. It has increased my knowledge. Every session by session of GR Foundation is increasing my knowledge. So thank you very much. And the authors have done very nicely. So congratulations to all the authors. And Pranjal, you were excellent. Yes.
Thank you so much, ma'am. I extend my sincere gratitude to you for chairing the session with great energy and for your guidance throughout.
Thank
Now,
you.
I would kindly request all of you to switch on your cameras for a quick snapshot of the virtual conference. Thank you, everyone. Smile, please. Okay. Thank you so much, everyone. Stay safe, stay healthy. Thank you for
Thank
attending the
you.
session.
Yes. Bye bye, everyone.